I can already see that some of you are looking uncomfortable. Okay, I'll make you more comfortable. I was going to start to do the answers, and I could see some of you just needed the name right there. So good old Anne, she gets everything perfect. You figured it out, right, Marco? Yeah, okay. What does the word static mean? Yeah? Lacking in movement, sure. I would take that. I always like to breathe and come up with as short a definition as possible. I said, unchanging. Yeah. Static electricity, the difference. So by the way, the next unit, Jamie, we're going to look at is current electricity. Then instead of looking at electrons building up on insulators, so they can't go anywhere, so they're static, we're going to say, well, what if you put them in a wire? Well, then now they're going to flow along the wire. And we'll talk about how all of your household circuits work. And I'll probably sneak in some Physics 12 with you because you all look smart. When an object is negatively charged, does it have more electrons or protons? Jordan, what'd you say? Jordana, what'd you say here?
Electrons.
Yep. Could I just go E- instead of writing the word electrons because I have a lovely abbreviation? I'm going to circle the correct answer. Conductors allow or don't allow electrons to travel freely? Allow? Okay. Insulators allow or don't allow electrons to travel freely? Don't allow. So those are two words you need to know. That's absolutely going to be part, I think, of a matching section or something like that. Okay? Allowing charge to flow into the earth is called grounding. That's a term that makes sense because what's another word for earth? Ground, right? I thought grounding was something else. No, Jimmy, that's what happens when you don't do your homework. That's different. Your response should have been, I always do my homework, Mr. Duke. You missed out. I thought I set you up right there, and you let me down. Force is defined as? What did I say a force was? Push or a pull? Quick pencils down. That's the wrong definition. That works at a higher level. If you get your PhD in physics, you're going to say a force is an interaction between two subatomic particles. It's an exchange of baryons. We're not going to get all the way down there, but I do have to point out that we can go further. You can go always all the way down to what we call the quantum level. Pick your pencils up. Push or a pull is what I teach my Physics 12s too, but I always explain to them that's technically not quite right. Contact forces can only affect objects that they can touch. In fact, if you're really clever, you would say contact. Contact forces can only affect objects that they can contact. Nick pointed out, and he is right. And it's funny, my answer key from 2 years ago, I fixed it then, but I forgot to fix it in my original, apparently. Dumb. So, we've talked about a force. It's a push or a pull. Contact force is one where you're touching it. An electric force is a push or a pull between what? Yes. Good. An electric force is an example of a or an blank because it can act on something blank. What'd you say here? Okay. You could say, if you wanted to do it in one word, indirect, or you can say action at a distance. Force. I hate that second term in brackets because in physics we say you can't have action at a distance. This is where I went on my big rant about electric fields and invisible tentacles like an octopus, but I'll accept that because that's what the textbook is teaching you. You're going to also find if you're in Science 10 next year, if you're using the old textbook and if you're doing the old physics, it's wrong in Science 10 too. It drives me crazy. Because it can act on something, what? At a distance that it's not touching, from far away. So I would take all of those, okay? That's what makes electric force unique. You all did where you charged your magic wand, and when you moved it near the paper without touching the paper jumped up. In Star Wars, we call that the Force. In the real world, we say, no, we can explain that. There is a force. It's an electric force, not the mystical force from Star Wars. But we have to have an explanation. If we don't, then we are allowing magic and witchcraft in a weird world that we don't live in. Complete the following sentences using the following terms. Each term may be used more than once. A negative charge is repelled by a what charge? I abbreviated negative as minus VE. A positive charge will blank a negative charge. Attract. Can I move that a little higher? Right there? No. No. Okay, it's going to go there. A charged object.
Attract.
Good. Why? Why? What do we call it when we temporarily move charges around, but it's not permanent? It begins with the letter I. Yeah, we can induce a charge in a neutral object. We can move the electrons and the protons kind of around a little bit, and so we can get whatever side we need that's closest to the object to be the attractive charge. A negative object attracts an unknown object. The unknown object could be what or what? Positive or neutral. That's the one that a lot of people forget about. So it could be, I'm just going to handwrite positive or neutral. A positive object blank a positive object. Repels. Good. Now we're going to get into some charge diagrams. There is going to be a page on your test where I'm going to ask you to mention those little charged diagrams with pluses and minuses on them to kind of show what's going on. We've done a few of them in the notes, so here's one example. So this is the hanging spheres, those little styrofoam balls that we had hanging from the little thread. It says, use the diagram below to answer question 11. Imagine the same setup. A positively charged object is attached to a table as shown above, right there. Use an arrow to indicate the direction of the force on the negative You know what? That gets you 1 mark as far as I'm concerned. The positive object.
Because like charges repel.
Good. What about the neutral object? Okay. So give you out of 3 for that. Use the words increased or decreased to complete each of the following statements. To increase the electric force between two charged objects, the distance between them should be decreased? Yeah, move them closer, force will be stronger. That's why you had to move the magic wand close enough to the paper before it would jump. It wouldn't do it from far away. To increase the electric force between two charged objects, the amount of charge on one or both of the objects should be
increased.
To decrease the electric force between two charged objects, the distance should be
Increased.
And what about D? Decreased. We actually, in Physics 12, learn how to calculate the force. For those of you who are wondering, the equation for electric force is K Q1 Q2 over R squared, which looks terrifying. It's not. Q1 is the amount of charge on the first object. Q2 is the amount of charge in the second object. Notice they're on top of the fraction, which means as they get bigger, the force gets bigger. R is the distance from the center of the object. We use R for radius because they're circular charges. And you'll notice it's on the bottom of the fraction, so when it gets bigger, your answer gets smaller, which matches exactly what we say. What I haven't told you is that it's actually R squared. If you go twice as far away, you have 4 times weaker. If you go 3 times as far away, you have 9 times weaker. If you go 4 times as far away, you have 16 times weaker. So you don't need to know any of that, but you will if you take Physics 12 with me. Conduction is charging a neutral object by contacting. If you really, really wanted to go further, you could even say by, I'll put in brackets, transfer of charge, electrons, yep. Induction is charging a neutral object by not touching. And here again is where the textbook said to you it was temporary. I would say I showed you a way where we could do a permanent charge by being clever, so I disagree with the textbook. But if you say temporary, I won't mark it wrong because that's what the textbook teaches, even though it's wrong. Yes?
I'll put it in correct.
Yep, I take that totally. Absolutely. That's the dumb way I told you to remember it, yes? Yeah, always come up with silly ways to remember things, much easier. If you charge an object using conduction, you have transferred electrons to the object or caused the electrons already in the object to move without changing the number of electrons. A or B? Okay. What's B?
Induction.
That's induction. Turn the page. What was that? Yep. Why will a neutral object be attracted to a charged object? So here's what you said, and I'm going to be fussy. You said a neutral object will be attracted because it's neutral. That's what no charge means. That's not an explanation. That's repeating the question. I'm going to be fussy. Yes? Yeah.
It connects as a positive or negative, so positives or all the protons.
And by the way, I should really say the protons never move because they're locked in the nucleus. The electrons always move, but an electron moving to the left mathematically is the same as a proton moving to the right, so we'll pretend the protons are moving even though they're really not. So if you said that, I'd be okay with that because we are going to pretend the protons are moving. Have I gone on my rant about how Benjamin Franklin got the charges wrong? He should have called the electrons positive. It would have made it so much simpler. Anyways, okay. So I would take that. Here's what I wrote. What did I write? I wrote charges in a neutral can move around, comma, creating charged sections within the neutral object, within the object. And so you can create a charged section closest to the other charged object, and it will be unlike, and it will attract. Not as strong as like and unlike, but strong enough that you saw, because when you did the magic wand with the paper, what was the charge on the paper? It was neutral, but that was enough to overcome gravity and have it jump up off the table. Right? What are the units for charge? What do we measure charge in? Coulombs. This will be a good matching question as well. You might recall I told you 1 coulomb is massive. If you absorbed 1 coulomb all at once, you'd probably not just die, probably you'd burst into flame in your clothes. It would be one of those sci-fi movie deaths that you see with lots of special effects. Not quite that dramatic, but close. Yeah? About there, yeah. So you can imagine 1 coulomb is 1/15 of a lightning bolt. It's a lot. Now, having said that, in here is about 1,000 coulombs. But the circuit is designed so that it can only trickle out very, 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 very slowly. And that's why you can put your tongue on this, you can hold it. Technically, I'm completing the circuit right now on this battery with my hand. Am I dying? No. So even though, don't confuse lots of charge with how fast you have to absorb the charge. It's all about how fast you have to absorb the charge. And if you absorb the charge very slowly, substance has 25,000 electrons, 24,500 protons, 25,000 neutrons. Is it positive, negative, or neutral? Negative. Object A is negatively charged and it's attracted to object B. What possible charge is object B? Good. Positive or neutral. That second one is the one a lot of kids forget. Okay, suppose we have 2,000 protons and 2,000 electrons. What's its charge? Neutral? So does neutral mean no electrons? No. In fact, any object with atoms has to have protons and electrons. So all matter. Yeah.
I was just curious, for the one that's positive or neutral,
Yep.
if someone were to write just positive, would that be a
I would give them one. You know what? I would probably hint at you. I would probably make this question worth 2 marks and I would give you 1 out of 2. So for 1 mark, I would give you 0.5 out of 1. Yep. Half mark for positive, half mark for neutral. Okay. So yeah, just because it's neutral doesn't mean no protons and no electrons. If it has matter, it has to have protons and electrons. We're saying it's the same number. After touching another object, object A becomes positively charged. What can we say about the number of protons after object A becomes positively charged? There are more protons, there are less protons, or the number of protons is unchanged?
The number of protons
Mentioned what? But I thought it became positive. Didn't it lose protons? So a lot of people will say, oh, there's more protons. The protons are locked. Why, by the way? You know what? I think on the test I might even have you, for like a couple of marks, do a quick sketch of an atom again, because that's so fundamental. I might say, draw a picture of an atom showing me where the neutrons, the protons, and the electrons would go. Any generic atom. Doesn't have to be a specific one from the periodic table, because that alone, Marco, explains an awful lot. Why can electrons move? Because they're on the outside. What can you say about the number of electrons after object A becomes positively charged? There are more electrons, there are less electrons, or the number of electrons is unchanged?
Less.
I didn't ask you this question, but what can you say about the other object in this situation? More electrons, less electrons, or unchanged? Yeah, you're going to learn later on that electrons and protons can't vanish. We call it conservation of charge, so they always got to go somewhere. So, well, I lost some electrons here. They went somewhere else. They didn't just magically disappear. I think if you add that up, I think it adds to 34. Does that work? Let's see. So most of these are little 1 mark question. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one's out of 5. So that's 14. Plus 3 is 17. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I think, is it out of 32, not 34?
But if you do
On 10D,
the 2 point, it's positive or neutral.
so you're going to say that's 33? And is there another one like that I missed?
20.
So this one here is going to be worth 2 marks. And I did the same thing for number 20. I knew I'd added it up right the first time. Positive or neutral. Okay, I'll make that worth 2 marks. And you can get 1 for each. Okay. So can you give yourself a lovely score out of 34?